Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir. Can I ask you a doubt related to the question paper, to the test that was conducted?
Yeah, you can ask.
So I have a doubt in the last question, the 15th question. So according to me, none of the answers match. None of the options don't have the answer that should be the answer of the question.
What is the question, man? Hello?
Yes, sir. Just a minute. I'll say the question.
Yeah, good afternoon, everyone. How are you?
Good afternoon, sir.
Afternoon, sir.
Afternoon, sir.
Yeah, which
Good
portion is
afternoon,
going
sir.
on? Yeah, which portion is going on?
Sir,
Good
phase
afternoon,
rule.
sir.
Phase rule. Okay, the first unit is completed. What is the first unit? Applied chemistry, how many units are there? Speak out.
Four.
Four
Four.
units.
Four.
Four, sir.
Number one.
Technology of
Water
water.
technology,
Technology, water technology.
Number two.
Fuels, combustion,
combustion,
cement.
Cement.
Okay. Number three.
Corrosion and phase rule.
Corrosion and phase rule.
Okay. Number four.
Lubricants and polymers.
Lubricant and
Lubricants and
polymers.
polymers. Yeah, in the technology of water, the unit one, what is hardness and its determination, what is alkalinity and its determination, what are the boiler troubles, sludge, scale, priming, foaming, carryover, corrosion, caustic embrittlement. The next one is softening of water. What are the softening of water? There are two methods are there: external treatment, internal methods. External methods: lime soda process, zeolite process, ion exchange method. Internal process: Colgan conditioning, carbonate conditioning, colloidal conditioning, phosphate conditioning. This then degree of hardness, then domestic water treatment along with breakpoint chlorination. That unit, that topic is also there. This is about the hardness. The next one is fuel combustion and cement. Okay, that combustion portion at okay, which portion is going on in the second unit?
Carbonization of coal.
Uh,
Carbonization of coal.
Carbonization of coal, sir.
Okay, carbonization of coal. Yeah. Okay, that means in the second unit, okay, what is calorific value? What are the units of calorific value? Then determination of calorific value by using Baum calorimeter. Then after that, Dulong's formula, corrected equation, corrected gross calorific value equation. Then Dulong's formula, theoretical calculation of calorific value. Then after that, analysis of coal. Then after that, in the analysis of coal, there are two methods are there: proximate analysis, ultimate analysis. In the proximate analysis, again that method includes four: that determination of moisture, determination of volatile substances, determination of ash, and fixed percentage of carbon. Then in the ultimate analysis, percentage of carbon, percentage of hydrogen, percentage of nitrogen, percentage of sulfur, and then percentage of oxygen. This is about the analysis of coal. Then after that, carbonization of coal, that conversion of coal into coke in absence of air or otherwise in absence of oxygen is called as carbonization. That normally Beeves oven method, Otto Hoffman oven byproduct method is there. So Otto Hoffman oven byproduct method is very, very important. You have to remember, especially the extracting of valuable chemicals from the coal gases. Then after that, flue gas analysis, the gas which is coming out after combustion of any fuel, that is called as flue gas. Then the flue gas analysis is there. That means if the flue gas is having carbon dioxide, carbon monoxide, oxygen, I think this topic yet to complete, isn't it? Flue gas was not completed now.
No, sir.
Yeah. Then after that, I think Madam may start the cement portion. Cement portion, only two or three important questions are there. That limited portion is there. It's not a big deal. The next, I started the phase rule. What is phase rule? What is the mathematical formula of phase rule? Okay, that explains what. That introductory part has already been okay completed. What is the phase rule? Yes, okay, till now only 62 have joined, man. This is very bad. What happened? Our class strength is 70?
70.
Yes, sir.
20.
70. What about others? Yeah. So in the phase rule, what is the introduction? Normally, the American physicist Willard Gibbs scientist derived one mathematical formula based on thermodynamic principles. What is that mathematical formula? F is equal to C minus P
F
plus
plus P equals to C plus 2.
you remember either that or otherwise this, or otherwise both are also no problem, but normally okay students are getting confusion. F plus P is equal to C plus 2, or otherwise F is equal to C minus P plus 2. So this is the one formula he gave. Then how he gave that formula? Yes, the derivation part is also there, but here that is not required, because in our curriculum that derivation was not there. In higher semester the derivation is there, the simple derivation. Even I am teaching it chemical engineering 4th semester, applied physical organic chemistry. See here how he derived the mathematical formula based on thermodynamic principles. He studied some equilibrium systems, how the heterogeneous equilibrium systems are existing in the atmosphere. He studied, then after that he gave this mathematical formula. That means if you know this, based on this mathematical formula, we can able to determine how many number of independent variable factors are required in order to study that equilibrium system. So in that, according to Willard Gibbs scientist, if any equilibrium system is there, that equilibrium system does not influenced by either gravitational force, electrical force, or magnetic force, but that any equilibrium system that may be influenced by either he considered only temperature, pressure, and concentration. That means these are the assumptions of Willard Gibbs scientist. According to Gibbs scientist, if any equilibrium system is there, that may be influenced by either temperature, pressure, concentration, but that equilibrium system does not influenced by magnetic force, electrical force, or any other external forces. So these are the assumptions of Willard Gibbs scientist. But here F stands for what? Degree of freedom.
Sir,
C stands for
sir, are you presenting this PPT?
no, I am not presenting PPT, just I am revising.
Okay, sir.
This is this portion has been already completed. Okay.
Yes, sir. Last time you were saying and the PPT was not there, so you told us like you were presenting the PPT.
Okay. Once again, I am sharing. No problem. Don't worry. Okay. After sharing, let us revise. Is it okay?
Visible, sir.
Oh, okay. Thank you. Yes. So now where we are, what is the mathematical formula? That formula is F is equal to C minus P plus 2, where F stands for degree of freedom. Now, where C stands for number of components, P stands for number of phases. But then, what is the definition of degree of freedom? What is the definition of components? What is the definition of phase? The definitions were already completed in the last class. Let us assume that what is the definition of phase? The definition of phase is homogeneous, physically distinct, mechanically separable from a heterogeneous system is called as a phase. So normally in the water system, that means when all the three phases are existing in equilibrium, then how many number of phases are there in the water system?
3.
3 phases are there: solid, liquid, and vapor. Please remember, phases I am discussing. Now, say for example, water plus ethanol, how many number of phases are there?
2.
1.
Are one man? Who said 2? Okay. So this is about the phase. Now next one is number of components. What is the definition of component? The definition of component is minimum number of chemical constituents which describe the equilibrium system. This is our straightforward definition for our understanding. But as per the textbook, the term component is defined as the least number of independent chemical constituents in terms of which the composition of every phase can be expressed by means of chemical equation. That means if you know the minimum number of chemical constituents, then automatically we could able to guess what type of other chemical constituents and as well as what is the composition, what is the phase of that component, that we can guess. Let us assume that water system has 3 phases. That means at equilibrium, that where all the 3 phases are existing in equilibrium, that means ice is equilibrium with water and that is equilibrium with vapor. So all the 3 phases are existing in equilibrium. So here, if you discuss about component, how many number of chemical constituents are there? Yes, how many number of chemical constituents are there?
1.
So one.
Now, only one. Please remember, components only one. Why? Because in the solid portion, ice in the ice is there, solid portion. What is the composition? H2O is the composition. Water, there also H2O is the composition. Vapor, there also H2O is composition. So here only one composition is there, and that is the minimum number of chemical constituents which describe the equilibrium system. So water system which is having only one chemical constituent. Similarly, if you take another example, let us assume that decomposition of calcium carbonate. Yes, this was also discussed. Normally, what is the standard equation? The decomposition of calcium carbonate. The calcium carbonate may decompose at higher temperature, and that is around 900 or 800 degrees centigrade. That may decompose, and that is going to produce the calcium oxide plus carbon dioxide. Okay, calcium oxide is also a solid, carbon dioxide is the gas. See, here it was written calcium carbonate, that gives rise to calcium oxide plus carbon dioxide. Here, how many? Looking to the chemical reaction. Forget about the Willard-Gibbs scientist. Looking to the chemical reaction, here calcium carbonate, one chemical constituent is there, calcium oxide is there, carbon dioxide is there. So 3 chemical constituents are there. This is about in general manner. But as per the Willard-Gibbs scientist, his definition, according to Willard-Gibbs scientist, what is the definition? Minimum number of chemical constituents. That means, let us assume that calcium carbonate minus CaO. Okay, let us assume that CaO. Then what happened? You don't know. Okay, what it is here. Let us assume that you don't know this. Okay, totally you delete this. Then calcium carbonate minus calcium oxide. Then what is the third chemical constituent? Yes, tell.
Carbon
CO2?
dioxide.
Carbon dioxide only, because the calcium carbonate decomposition at any cost, that is going to give either calcium oxide and as well as carbon dioxide. So that means according to Willard-Gibbs scientist, or otherwise, okay, according to Willard-Gibbs scientist, we can understand this reaction like this. The calcium carbonate minus calcium oxide, that is going to give the carbon dioxide. Or otherwise, instead of calcium oxide, if you keep carbon dioxide, then what is the third chemical constituent? Yes, tell.
Calcium carbonate.
Calcium oxide. Okay, समझ में आ रहा है?
Yes, sir.
Yes, sir.
Yes.
Okay. That means the removal of carbon dioxide, the calcium carbonate minus carbon dioxide, that is going to give the calcium oxide. So what is the third chemical constituents we can expect, and at the same time what is the phase of that? Yes, calcium carbonate minus CaO, that is going to give carbon dioxide. What is the phase of carbon dioxide? Gas.
Gas.
Somebody are
Gas.
phase. So similarly, okay, we can guess what is the third chemical constituent. Hence, here, according to Willard-Gibbs scientist, the number of components are 2. Then here another example is also there. PCl5, that gives rise to PCl3 plus chlorine. Once again, PCl5, that gives rise to PCl3 plus chlorine. So here, same PCl5 minus chlorine. That is going to produce the PCl3.
PCl3.
Okay. So like this, we can guess what is the third chemical constituent. So this is comes under number of components. So this was already discussed. Now next one is degree of freedom. See, what is the definition of degree of freedom? The minimum number of independent variable factors should be specified in order to describe the equilibrium system. That means to study any equilibrium system, first of all, you are required to fix the temperature, pressure, and concentration. So these are the mandatory as per the Willard-Gibbs scientist. See here, minimum number of independent variable factors. See here, he considered the 3 independent variable factors. What are those? Temperature, pressure, and concentration. Yes, some other independent variable factors are also there, which are influencing the equilibrium system. But he considered, Willard-Gibbs considered, if any equilibrium system is existing, then that system may be influenced by temperature, pressure, and concentration. You remember as it is. Why? How? Okay, don't arise these questions. Simply remember, because that is his understanding and he gave the derivation. Now, later it was proved wrong, but now this was there. What are the phase rule? That proposed by Willard-Gibbs scientists that we are discussing. Now, see, monovariant or univariant means, that means one independent variable factor should be fixed in order to describe the equilibrium system. That we discussed. If water and vapor is there, water boiling, water is equilibrium with vapor means that is the boiling point. That means the temperature may be 100 degrees centigrade. So if temperature is 100 degrees centigrade, okay, pressure is 1 atmosphere pressure. So F is equal to 1. That means water is boiling. Normally here, as per the normal conditions, the temperature is 100, pressure is 1 atmosphere. So F is equal to 2. But here Willard-Gibbs scientist, minimum number of independent variable factors should be specified. So here, you are required to specify any one. If you know temperature, automatically we can guess pressure. If you know pressure, then automatically we can guess temperature. So F is equal to 1. That is the one. That is one of the best example. Say for example, a triple point is also there. The triple point we will discuss. That means that is the non-variant. Non-variant system, when it will be the non-variant system, yes, if ice, that is equilibrium with water and that is equilibrium with vapor. At these conditions, if ice is equilibrium with water and vapor, that means all the three phases are existing in equilibrium. At that condition, the degree of freedom is 0. And why it is 0, sir? Yes, because the temperature and pressure are constant. That means temperature is 0.0098 degrees centigrade. That means approximately 0 degrees centigrade. Then pressure is 4.58 mm of Hg. That means these are the experimentally proved conditions. That means at that particular conditions only that equilibrium system can exist. If you alter the temperature, if you change the temperature, if you increase the temperature, or if you decrease the temperature, any of the phase may disappear. That means let us assume that if you alter one independent variable factor like temperature, if you increase the temperature, then what happens? Solid phase may disappear. Then there may be liquid may be equilibrium with vapor. If you decrease the temperature, then what happens? Vapor phase may disappear. That means solid may equilibrium with liquid only. So these are the problems are there. So that system is when all the three phases are existing in equilibrium. That system is called as non-variant. That means there are three are there. Monovariant, that means F is equal to 1. Bivariant, F is equal to 2. Trivariant, F is equal to 3. Non-variant, F is equal to 0. F is equal to 0 means what? That the independent variable factors are constant. You cannot vary either temperature or pressure or constant according to Willard-Gibbs scientist. Simply you remember what is the definition of degree of freedom. The minimum number of independent variable factors should be specified in order to describe the equilibrium system. What are those independent variable factors? Temperature, pressure, and concentration. This much. So with this, we could able to conclude what are the definition. That means F is equal to C minus P plus 2. In that equation, what is F? We discussed. What is P? We discussed. What is C? We discussed. Now, next one is application of phase rule to one component system. Now, okay, this is only in our curriculum, application of phase rule to one component system. Now, see, can you give the example for one component system? Which system is example for one component system?
Sir, water system.
Yes, which we are discussing. The water system is the example for one component system. Why? Yes, ice is equilibrium with water, that is equilibrium with vapor. So in all the cases, ice, what is the component? H2O. Water, liquid, component H2O. Vapor, component H2O. That means in all the three phases, H2O is the component. So that is a one component system. There are number of systems are there. Sulfur system is also one component system, because monoclinic sulfur, rhombic sulfur, different sulfurs are there. But its chemical composition, if you discuss about chemical, then everywhere sulfur element is there. So that is also one component system. One component system, best example is water system. That is there in our curriculum, that only we are discussing. One component system. So in your example, in your examination, the question may come like this. Okay, define phase rule and explain the application of phase rule to water system. This is a straightforward question. Or otherwise, that means water system is there in your exam. Then water system application they may ask. Or otherwise, define phase rule and explain the application of phase rule to one component system. One component system is nothing but water system is the one component system. So by default, you are required to write this whole story in your examination. Now, see here what happened in the phase rule. The Willard Gibbs scientist, okay, did some experiments. Practically, he did some experiments. Then, based on that experimental results, he has shown in the form of graph, in the representation of graph. Graph means, yes, he considered. See here, this is the phase diagram for the water system. That means he considered pressure and temperature. These two independent variable factor. Then he considered these two. Then he gave one representation, graphical representation. So every time the Willard Gibbs scientist, he studied either one component system or two component system or three component system, any system he studied. Then he represented all the results in the graphical format. He gave the that diagram. What is the phase diagram for one component system? Yes, he considered pressure and temperature. The temperature is on x-axis, pressure is on y-axis. So by application of this pressure and temperature, he gave this diagram. This diagram represent what? Yes, that we are discussing. Now, phase diagram for one component system. Here, different curves are there. What are those curves? First of all, what is the x-axis? This is the x-axis. This is the temperature. Y-axis, this is the pressure. Now, see here, one curve is there. This curve is CT curve is there. Then here, AT curve is there. Then here, TC or otherwise T, here A, B. You can assume that here it is, you can keep one curve, that is B curve. Yes, this is the TC is there. Don't consider that. Here you can keep B. That means CTB. This one area. Then CTA. This is another area. Then ATB. That means this is another area. That means in the phase diagram, two things we can discuss. What are those? Areas or otherwise places. Three places are there. Then at the same time, three boundary lines are there. Three curves are there. Boundary lines or curves are there. Okay. What are the boundary line? Yes, here CT is one boundary line. Why it is called as a boundary line? Yes, first of all, we will discuss how many areas are there, places are there. In the phase diagram, there are three phases or three areas are there. Areas, A-R-E-A-S, areas, or otherwise places, P-L-A-C-E-S, places. What are the area? See, in the phase diagram, C-T-A, or otherwise A-T-C. This area, the left-hand side area, the left-hand side place, is occupied with solid. That means ice is there. Then similarly, C, here C, T, B is there. Here you can keep it B. So C, T, B, this area, this place is occupied with liquid. See, here it was liquid. It was mentioned. Then similarly, A, T, B. Here you have to keep B. So A, T, B. So below of that area, or otherwise that place is occupied with vapor. Yes, in the phase diagram, how many areas are there?
3.
3 areas are there. What are those?
Solid ATC, CTB and ATB.
Yes, very good. ATC left hand side portion, that area is occupied with solid. That means ice. Then CTB, this area, okay, upper portion, that is occupied with liquid. Then below portion, ATB, that below of the portion is occupied with vapor. Okay, that's fine. That means in the phase diagram, there are 3 areas are there. ATC, solid, occupied with solid. Then CTB, occupied with liquid. ATB, occupied with vapor. That's fine. Now, 3 boundary lines are there. What are those 3 boundary lines? Yes. See here, C and T. This is one boundary line. Why it is called as boundary line? Boundary line. BOUNDARY. Boundary. That means edge line. Boundary line. See, boundary line. Why it is called as boundary line? Because this boundary line is separating solid from liquid. See here, it is clearly mentioned. This area is occupied with solid. This area is occupied with liquid. And this boundary line is separating solid from liquid. So hence it is called as boundary line. And here in this boundary line, we can, here in this boundary line, solid portion is equilibrium with liquid portion. That means ice is in equilibrium with liquid, or otherwise ice is in equilibrium with water. Hence that curve is called as melting point curve. Why it is melting point curve? Because ice is melting and that is converting into liquid. अरे समझ में आ गया कि नहीं आ गया?
Yes, sir.
Yes, sir.
Yes, sir.
Once again, be alert. See here, one boundary line is there. That boundary line is CT boundary line is there. See here, this is the CT boundary line. This boundary line is, why it is called as boundary line? Because as it is separating the solid portion from liquid portion. That's fine. And at the same time, this boundary line, ice is equilibrium with liquid. Actually here we have to keep equilibrium symbol. Okay, if it is, if you are explaining on board, I could have mentioned the equilibrium symbol. That means arrow mark. But here, this is the, okay, here you are required to keep arrow mark, and this curve is called as melting point curve. And similarly, another curve is there. That curve is, okay, TB. Okay, here B is there, here T is there. TB curve. So TB curve is TB boundary line, or otherwise TB curve. TB curve, or otherwise TB boundary line, or TB boundary curve. Anyone you can, okay, you can say, don't worry. So TB boundary line, so that is separating, okay, which phases? Yes.
Liquid vapor.
Liquid vapor.
Yes. That means TB boundary line is separating the liquid portion from vapor portion. Hence it is called as TB boundary line. See here, that means here which phases are existing in equilibrium?
Liquid and vapor.
Yes, liquid and vapor. So liquid and vapor means that is simple boiling point curve. So TB curve is also called as boiling point curve, or otherwise vaporization curve. Why it is called as vaporization curve? Because the liquid is converting into vapor. So hence this curve is called as vaporization curve or boiling point curve. So that means 2 curves has been completed. Then another curve is also there. That is the AT curve or otherwise TA curve. See, okay, you can say either AT curve or otherwise TA curve. Both are same. Don't get confusion. So TA curve is separating solid from vapor. See here, okay, this curve left hand side solid is there, and this curve right hand side, that means down portion vapor is there. So hence, okay, as it is separating solid and vapor, this curve is called as sublimation curve. What is sublimation? Where the solid is directly converted into vapor. That means there is no intermediate phase, that liquid phase. So directly, if the solid is converting into vapor, that phase is called that is called as sublimation curve. That is the sublimation boundary line, where the solid, that means ice, is directly converting into vapor. Hence, that is called as sublimation curve. So that means, there a solid, that means ice is equilibrium with vapor. So that means there are three boundary lines are there, three curves are there. The first curve is CT curve, where ice is equilibrium with liquid. That's fine. That is called as melting point curve. Then another curve, TB curve is there. That curve is separating water from vapor. So there water is equilibrium with vapor. And similarly, TA curve is there, or otherwise AT curve is there, where solid is in equilibrium with vapor. So hence that is called as sublimation curve. So melting point curve is there, boiling point curve is there, that means vaporization curve. The third one is sublimation curve is there. Three curves are there. So three curves are there, and at the same time, three areas are there. What are those areas? ATC, that area is solid. Then CTB, that area is liquid. Then ATB, that area is occupied with vapor. Now, okay, now come to the application of phase rule. That means apply the mathematical formula of phase rule. See, similarly here, 2 degrees of freedom, okay, regions, okay, boundary line, okay. Let us assume that apply the mathematical formula on any region or otherwise areas or otherwise places. Okay, all are same places. In some textbooks they are writing regions, some textbooks they are writing areas, some textbooks they are writing places. That means let us assume that here which area shall we take? ATC area shall we take? Okay, let us consider that. Okay, in the area, okay, ATC, okay, this area or ATC region. Yes. Now at the ATC region, which phase is there? Whether solid phase is there, or liquid phase is there, or vapor phase is there? Which phase is there?
Solid.
Solid. That means ice is there. Okay. Once again, I am discussing here ATC. Let us discuss one area, ATC. ATC area is occupied, or ATC region is occupied with solid. Now apply the mathematical formula phase rule. What is that phase rule? F is equal to C minus P plus 2. Now, F is equals to C. C is number of components. Ice is there, H2O. So, number of components are 1. Then minus P. Minus P means how many number of phases are there? Only one phase is there because that is ice. So, 1 minus 1. Okay, P in place of P, you substitute with 1 plus 2. So, plus 1 minus 1 get cancelled. Then that is equal to 2. That means to study the equilibrium system in the region of ATC, how many number of degrees of freedoms are required? 2 degrees of freedoms are required. This is the conclusion. अरे समझ में आ रहा है कि नहीं आ रहा है?
Yes, sir.
Yes, sir.
Yes, sir.
Similarly,
Yes, sir.
let us assume that another
Yes,
area you can take. Okay, another area. What is that another area? Okay. Okay, another area. Another area means, yes, here you can take anyone, CTB. Okay, CTB. Yes, in the CTB area. That means here CTB area. CTB area or otherwise CTB region. Then again same you apply. Here water is there. Apply the mathematical formula. F is equal to C minus P plus 2. Water, number of components 1. Number of phases 1 because only liquid is there. Then F is equal to 2. That means here also at CTB area also F is equal to 2. Then similarly another area you can take ATB. ATB also you can take, that portion is occupied with vapor. So at vapor, okay, ATB area, again vapor is there. You apply the mathematical formula. F is equal to C minus P plus 2. Number of components vapor 1. Number of phases only gas phase. Then 1 minus 1 plus 2 plus 1 minus 1 get cancelled. Then F is equal to 2. That means in all the regions, the conclusion part I am saying, that means in all the regions, either this region or this region or this region, if you apply the mathematical formula, then you would be getting the 2. That means 2 degrees of freedoms are required. That means temperature and as well as pressure or both are required to study the equilibrium in the areas. Okay, now go to boundary line. If you come to boundary line, you can understand what we discussed during the definitions. Don't get confused. In the boundary line, let us assume that BT curve is there. That means TB or otherwise BT curve is there. BT curve is liquid is equilibrium with vapor. Water is equilibrium with vapor. So if you go through it, okay, that BT curve, water is equilibrium with vapor. Then apply the mathematical formula F is equal to C minus P plus 2. Okay, here पागल हैं ये लोग, कुछ नहीं लिखा है, ऐसे ही कॉपी करके छोड़ दिया. ओके, कुछ लिखा है, क्या लिखा है मुझे समझ में नहीं आ रहा है. ठीक है. See, water is equilibrium with vapor at BT curve. F is equal to C minus P plus 2. Here, water and vapor in both cases number of components 1, and here number of phases. How many number of phases are there? Water is liquid phase, vapor is gas phase. 2 phases are there plus 2. So here this is equals to, okay, that is equals to plus 2 minus 2 get cancelled, then is equals to 1. That means here F is equal to 1. That means, see what I said, water is boiling. That means water is converting into vapor. So what is the temperature? Temperature is 100. Then what is the pressure? Pressure is 1 atmosphere pressure. That means even practically also, if you apply the mathematical formula, if you know the minimum independent variable factors, then automatically we can predict other one. So how we are getting the minimum independent variable factors? By applying this mathematical formula. That means in the BT curve, water is equilibrium with vapor. Then we erase this. I think the spelling is also wrong. Okay, some Britain English. Okay, now see, water is equilibrium with vapor. Apply the mathematical formula F is equal to C minus P plus 2. Similarly, you can take another boundary line. Let us assume that CT curve. In the CT curve, solid is equilibrium with liquid. Okay, that means solid is one phase, liquid is another phase. 2 phases are there. The number of components, only one component is there. Then same number of components 1, number of phases 2 plus 2 minus 2 get cancelled, then 1. That means on boundary line. Then another boundary line you can take. What is another boundary line? AT boundary line. In the AT boundary line, solid is equilibrium with vapor. That means solid is one phase, solid phase, vapor is gas phase, that is equilibrium. Then number of components only 1, then number of phases 2. So that means same here, number of components 1, phases 2. So plus 2 minus 2 get cancelled, F is equal to 1. So my conclusion is, on boundary line, how many number of degrees of freedoms are required? Only 1. This is according to this derivation, according to this equation. In the areas, how many number of degrees of freedoms are required? 2. In any area, ice area or water area or otherwise vapor area. So in all the regions, in all the areas or in all the places, how many number of degrees of freedoms are required?
2.
Then another conclusion is, in all the boundary lines or otherwise in all the boundary curves, how many number of degrees of freedoms are required?
1.
Only 1. So please you remember this. Similarly,
So at triple point.
At triple point, where what is triple point? Where all the 3 phases are existing in equilibrium. That means that phase, the solid, the CT boundary line and TB boundary line, AT boundary line, where all the 3 phases are existing in equilibrium, that point is called as triple point. The triple point means ice is equilibrium with water and that is equilibrium with vapor. That means where all the 3 phases are existing in equilibrium, that point is called as triple point. So here apply the mathematical formula at triple point. That means F is equal to C minus P plus 2. See, number of components 1 only, because solid H2O, water H2O, vapor H2O. So in all the 3 phases, number of components 1. Then in all the phases, yes, 3 phases are there. solid, liquid, vapor. All the three phases are there, plus 2. So 1 minus 3 plus 2. So here, okay, plus 2 plus 1 plus 3 minus 3 get cancelled, and that is going to 0. That means at triple point, where all the three phases are existing in equilibrium, you cannot fix any independent variable factor because you cannot alter either temperature or pressure. They are the constant. So that is the non-variant. You cannot vary the independent variable factor. And non-variant means, what does it mean? You cannot vary the independent variable factors. Temperature, pressure are there, but you cannot vary. So that is hence that is non-variant. That means that is 0. So in the phase diagram, my conclusion is the application of phase rule to one component. Simply you draw the diagram, then you explain the theoretically. That means first you consider areas, or otherwise regions. How many number of regions are there? Then in each region, which phase is there? Then apply the mathematical formula. Then you prove that yes, here components are 1, phases are 1, then F is equal to 2. That means here to study the equilibrium system in this area, 2 independent variable factors are required. Similarly, you write another area. So 3 areas you are required to write. Then 3 phases, 3 boundary lines you are required to write. Yes, boundary line. There are 3 boundary lines are there. What are those boundary lines? First one is melting point curve, boiling point curve, sublimation curve. 3 curves. In every curve, write the equilibrium system. Say for example, okay, this curve is there, melting point curve is there. In the melting point curve, CT curve, solid is equilibrium with liquid. So apply the mathematical formula, F is equal to C minus P plus 2, F is equal to 1. Hence, 1 independent variable factor is required. Then after that, same story, yes, okay, that same story may be repeated, but you are required to write. Then next boundary line, the TB boundary line is there. Then TB boundary line, liquid is equilibrium with vapor. Apply the mathematical formula, F is equal to C minus P plus 2. F is equal to 1. Hence, here to study the equilibrium system on this boundary line, one independent variable factor is required. Then similarly, another boundary line. Then next one is triple point. Okay. Then after completion of this, another curve is there. That is a TB dash curve. This is the B dash curve, not B curve. TB dash, because here we consider as B. Okay, this is the liquid and vapor, the boundary line, the vaporization curve. Vaporization curve is extended here up to B dash. That means this B dash means that curve is metastable curve. Metastable, that means that curve, that phase is not stable curve, because see here the temperature is 0 degrees centigrade. If you go through the below 0 degrees centigrade up to minus 4 degrees centigrade, sometimes the water may be existing in the liquid phase. See here, if it is going down, okay, as per our theoretical knowledge, this is in solid phase, so the water should be existing in the solid phase. But in some cases, which cases? If the water is ultra pure, there are no impurities at all, then what happens? Even at below 0 degrees centigrade also, the water may be existing in liquid state. Liquid state. Okay. Supercooled water. That phase is called as that curve is called as metastable curve. If you touch that liquid, then immediately they may get solidified. So that phase is called as metastable curve. Why it is metastable? It is not stable curve. That means below 0 degrees centigrade, obviously water is existing in solid state only. But sometimes, in some rare cases, if the water is ultra pure, then that may exist in the form of supercooled liquid. Supercooled liquid means in the form of liquid state. If you touch that liquid, then immediately they may get solidified. So this is about the phase diagram. Now next one is what are the advantages? Yes, the advantages. Phase rule is applicable to both chemical and physical equilibria. Then with the help of this phase rule, we can able to study all the equilibrium systems. So these are some of the merits are there. But what are the drawbacks? See here, he considered only for those systems which are in equilibrium. Yes, if the system is existing in equilibrium, then only you can apply the mathematical formula. If the system is not in equilibrium, or otherwise if the equilibrium system is slow, you cannot apply the mathematical formula of phase rule. That is also one of the drawback. Then here, another is he considered only 3 independent variable factors, that is temperature, pressure, and concentration. 3 degrees of freedoms he considered. But other than temperature, pressure, and concentration, yes, some other factors are also influencing the equilibrium system. These are some of the limitations. So this is about the phase rule. In your examination, this question will come 100 to 200%, no doubt at all. That means define phase rule and explain the application of phase rule to one component system. So what you are required to write? What is the introduction? Phase rule, who derived? Willard Gibbs scientist derived one mathematical formula based on thermodynamic principles. So that mathematical formula is F is equal to C minus P plus 2, where F stands for degree of freedom, C stands for number of phase components, and P stands for number of phases. So that normally, according to Willard Gibbs scientist, if any equilibrium system is there, so that does not influenced by gravitational force, electrical force, or magnetic force, but that may be influenced by temperature, pressure, and concentration. Now, F stands for degree of freedom. What is the definition? Minimum number of independent variable factors should be specified in order to describe the equilibrium system. Then give 1 or 2 examples. Then after that, C, number of components. C stands for number of components. The minimum number of chemical constituents to study the equilibrium system. Then give 1 or 2 examples. Then phase, homogeneous, physically distinct, mechanical separable from a heterogeneous system is called as a phase. Then you give 1 or 2 examples. That means one system, give one system, ice is equilibrium with water, that is equilibrium with vapor. So there, how many number of phases are there? 3 phases are there. Ice is equilibrium with water. How many number of phases are there? 2 phases are there. Ice is equilibrium with vapor. How many number of phases are there? 2 phases are there. Like this, you give the examples. Then after that, application of phase rule to one component system, draw the diagram, that representation. Then after that, explain the areas or otherwise regions. 3 regions are there. Ice region is there. Then water region is there. Then below that, vapor region is there. 3 regions are there. Then how many boundary lines are there? 3 boundary lines are there. The first boundary line is melting point curve. Then second one is vaporization curve. Then below that is the sublimation curve. Then after that, center point is triple point, where all the 3 phases are get connected. That phase is called as triple point. That means at that point, the ice is equilibrium with water, and that is equilibrium with vapor. That means all the 3 phases are existing in equilibrium. So at triple point, the triple point is a non-variant. That means the temperature and pressure are constant. You cannot vary, hence that is a 0. That is a non-variant. In the regions, how many number of degrees of freedoms are required? 2. In the boundary lines, how many number of independent variable factors are required? 1. Yes. अरे समझ में आ गया कि नहीं आ गया?
Yes, sir.
Yes, sir.
Yes, sir. 100%.
Alright, this topic is literally, it is very logical. Okay, this topic I am explaining to some other faculty members, temporary faculty members. Even sometimes if the classes are going on online, okay, I am substituting their classes. Sir, please engage my class and go and complete the phase rule and come back. Yes, I am taking. Alright, छोड़ दो करके. समझ में आ रहा है ना?
Yes, sir.
Yes, sir.
So this is the logic. As it is, you remember, don't worry. Okay?
Yes, sir.
Yes, any doubt in this? Do you have any doubt in this phase rule?
No, sir.
Prepare well, huh?
No, sir.
Okay, bye. For this combined section, taking attendance is very, very difficult हो रहा है भाई. Because everybody are, some rule numbers are similar now, so it is okay, it is getting difficult. See here, 49 rule number is there. Where is 49? I should get 49 3 numbers at a time.
Sir, 91 is present, sir.
ठीक है.
Sir.
91, 92.
But before the roll number, their parent branch section is already mentioned, like I, F, and K.
Okay. हाँ, yes. ठीक है. समझ गया.
Sir, I have a doubt regarding previous in previous classes, sir.
Yes, yeah. He's asked.
Sir, it's regarding there was a question in test, sir. Can I send you that question? How can I reach you on WhatsApp or
Send it to
mail?
WhatsApp, man. Send it to WhatsApp, okay?
Okay, sir. Okay, sir.
Do you have my number?
Yes, sir. I have your number.
Yeah, please send it through WhatsApp.
Okay, sir. Thank you,
do
sir.
you have Sasi Chawla chemistry book? I mean the PDF.
I think I don't have, man. Soft copy, huh?
Sir, can you send any one of the chemistry books PDF?
Okay.
Sir,
Sir, which book do you recommend for practice numericals?
Shashi Chawla, Jain and Jain, or SS Umre,
Like,
anyone.
okay.
sir, the demerit of this phase rule is we can't apply to non-equilibrium systems, no, sir. But we are
Non-equilibrium systems, or otherwise, if the equilibrium system is very slow, that case also we cannot apply the math phase rule. That is also one of the demerit.
applying for regions, no, sir. Without only at boundary lines they are in equilibrium, no, sir. Like solid is in equilibrium with liquid at the boundary line.
See, that whole, it is an equilibrium system. You consider it as a whole. समझ में आ रहा है ना?
Yes, sir.
हाँ, हम लोग ऐसा डिस्कस करेंगे ना, सभी को माइंड में है ना, वो उतर जाएगा. Okay, don't okay, split like that. It is a whole system is a heterogeneous equilibrium system. Okay?
Okay, sir.
Okay, sir.
Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Everybody understood or not? Come to video mode. I would like to see your faces.
Yes, sir.
Whosoever are available, please come to video mode. Huh? Only Sumran. Sumran Kumar, you are from which place?
But I am from Bihar, sir. Patna district.
Bihar. Sumran,
Yes.
are you understanding applied chemistry is my subject?
Yes, sir. I understand whatever you taught.
Okay. Vaibhav Kumar,
Yes, sir.
ठीक है? Are you happy?
Yes, sir.
You are from which place?
Sir, Bilaspur.
Bilaspur. Subhanshu Sharaf, what happened? Sitting in dark room.
Yes, sir.
Why?
Sir, it's comfortable, sir.
Okay. Okay, bye.
Yes, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.